Hello. In the last class, we have discussed king property, queen property of definite integral. Two important properties I have discussed in the last class. Today we will discuss about the jack property. The jack property says that if f is a periodic function, if f be a periodic function with period t, if f be a periodic function with period t, period means fundamental period. If f be a periodic function with fundamental period, if f be a periodic function with fundamental period t, then integral 0 to nt f of x dx, integral 0 to nt f of x dx equals n integral 0 to t f of x dx. Integral 0 to nt. So f is a periodic function with period t means f of x plus t. F of x plus t is equal to f of x. If f of x plus t is equal to f of x, then we can say that f is a periodic function with period t. So integral 0 to nt f of x dx integral 0 to nt f of x dx equals integral 0 to t f of x dx, integral 0 to t f of x dx plus integral t to t f of x dx plus integral 2t to 3t f of x dx plus up to n minus 1t to nt f of x dx. So this is equal to integral 0 to t f of x dx plus integral t to 2t f of x dx. Since the function is a periodic function with period t, then 2t to t, t to 2t f of x dx will be integral 0 to t f of x dx plus integral 0 to t f of x dx plus up to 0 to t f of x dx. How many times? N times. So this is equal to n times integral 0 to t f of x dx. N times integral 0 to t f of x dx. Okay. This is your jack property. To apply the jack property, we should know What are the fundamental period of the standard functions, trigonometric functions? Okay. Did you understand, students? Please write in the chat box. Is it clear to you? SBM Jagatsinghpur, Ramji Higher Secondary School. Standard functions and their fundamental periods. Standard functions and their fundamental period. Sin x, cos x, sec x, cosec x. Their fundamental period is 2 pi. Tan x, cot x. Their fundamental period is pi. Then sin to the power nx, cos to the power nx, sec to the power nx, cosec to the power nx. Their fundamental period is 2 pi. If n is odd, pi. If n is even, then tan to the power nx, cot to the power nx. Their fundamental period is pi. Mod sin x, mod cos x, mod tan x, mod cot x, mod sec x, mod cosec x. The fundamental period is pi. Okay. Let us come to discuss couple of questions on Jack property. Integral 0 to 10 pi mod of cos x dx. Okay. So mod of cos x is a periodic function with a period pi. So applying the property integral 0 to nt f of x dx is equal to n integral 0 to t. So here the fundamental period is pi. So we can write this is equal to 10 times integral 0 to pi mod cos x dx. You know, mod x is equal to x if x is positive, and mod x is equal to minus x if x is negative. In the interval 0 to pi over 2, cos x is positive, and in the interval pi over 2 to pi, cos x is negative. So this integral can be treated as 10 times integral 0 to pi over 2 mod cos x dx plus integral pi over 2 to pi mod cos x dx. Okay. So this is equal to 10 times integral 0 to pi over 2 mod cos x will be cos x, because in the interval 0 to pi over 2 cos x is positive, minus integral pi over 2 to pi cos x dx, minus integral pi over 2 to pi cos x dx. This is equal to 10 times derivative by integration of cos x is sin x. It will be evaluated between the limits 0 to pi over 2 minus sin x evaluated in the interval pi over 2 to pi. This is equal to 10 times sin pi over 2 minus sin 0 minus sin pi minus sin pi over 2. You know, sin pi over 2 is 1, sin 0 is 0, sin pi is 0, sin pi over 2 is 1. This is equal to 10 into 1 minus 0 minus 0 plus of minus 1, 1. This is equal to 20. I hope it is clear to you. Lucky, is it clear? Hello. Lucky, can you hear me? Write in the chat box, is it clear to you? Okay. Next question, integral 0 to 100. Next question, integral 0 to 100 e power x upon e power bracket x dx, where bracket is the greatest integer function. Integral e power x upon e power bracket x dx. This is equal to integral 0 to 100. Integral 0 to 100. Integral 0 to 100 e power x upon e power bracket x dx. This is equal to integral 0 to 100 e power x minus bracket x dx. X minus bracket x is equal to fractional part of x, and fractional part of x is the only algebraic function which is periodic in nature, having fundamental period 1. So this can be written as integral 0 to 100, integral 0 to 100 e power fractional part of x dx. So fractional part of x is a periodic function with period 1. This is equal to integral 0 to 100 into 1 e power fractional part of x dx. This is equal to 100 times integral 0 to 1 e power fractional part of x dx. When x lies in the interval 0 to 1, fractional part of x is equal to x. So this is equal to 100 integral 0 to 1 e power x dx. And the integration of e power x is e power x 100 into e power x evaluated to be evaluated within the limit 0 to 1. So 100 times e power 1 minus e power 0. This is equal to 100 times e minus 1. This is the final answer, right? I hope it is clear to you. Lucky, Is it clear? Then come to definite integral as the limit of the sum. Or evaluating infinite series by using definite integral. Evaluating infinite series by using definite integral. To evaluate infinite series by definite integral, we have to follow some steps. Write down the steps. Step 1. Write the infinite series. In summation form. Write the infinite series in summation form. Step 2. The expression after summation sign the expression after summation sign should be in the form of the expression after summation sign should be in the form of unmute. Okay. ଆସବୁ ଯୋଉ SBM କଲେଜ ଜଗତସିଂହପୁର ସେମାନେ କଣ ବୋଧେ ଇଣ୍ଟରାକ୍ଟ କରିବାକୁ ଚାହୁଁଛନ୍ତି ସେ କହୁନି ଆମକୁ ଟିକେ ଅନମ୍ୟୁଟ କରନ୍ତୁ। The expression after summation sign should be in the form f of r by n into 1 by n. This is your step 2. Step 3, replace sigma notation with the integral sign, r by n with x, and 1 by n with dx. Then limits of the definite integral, step 4, lower limit of the integral is equal to limit n tending towards infinity, lower value of r divided by n, upper limit of the integral is equal to limit n tending towards infinity, upper value of r or highest value of r divided by n. Hello, SBM? SBM, now you are unmute. You can talk to me. Let us come to discuss a question. Evaluate limit n tending towards infinity, limit n tending towards infinity, 1 upon n square plus 2 upon n square plus 3 upon n square up to n minus 1 upon n square. Evaluate limit n tending towards infinity, 1 upon n square plus 2 upon n square plus 3 upon n square up to n minus 1 upon n square. Our first step is to express the expression in the summation form. So we can write this is equal to limit n tending towards infinity, sigma summation r is equal to 1, lower value of r is 1, up to n minus 1, r upon n square, right? This is equal to limit n tending towards infinity, sigma r equals to 1 to n minus 1, r upon n into 1 upon n. Now our step 2 is over. Then in the step 3, we have to replace summation sign by integral sign, r by n by x and 1 by n by dx. This is equal to integral limit n tending towards this is equal to integral x dx, and the limit of the integral will be decided by what is the lower value of r. Lower value of r is 1. So lower limit of the integral is equal to limit n tending towards infinity, lower value of r upon n, limit n tending towards infinity 1 by n is 0. So lower limit of the integral is 0, and upper limit will be evaluated using limit n tending towards infinity, upper value of r is n minus 1 upon n, limit n tending towards infinity n minus 1 upon n is equal to 1. So this is equal to integral 0 to 1 x dx. Integral 0 to 1 x dx. X dx is equal to x square upon 2. It will be evaluated between the limit 0 to 1. So upper limit minus lower limit 1 upon 2 minus 0. So value of the infinite series is 1 upon 2. I hope it is clear to you. Is it clear to you guys? Please write in the chat box. Is it clear? SBM, Jagasimpur, Lucky. Lucky. Ramji Higher Secondary School. Okay. Next question. Limit n tending towards infinity. 1 by n plus 1. 2 by n plus 1. Sorry, 1 by n plus 1, 1 by n plus 2, up to 1 by n plus limit n tending towards infinity. One by n plus 1 plus 1 by n plus 2 plus up to. Sir, we don't understand question. Which question number 1 you didn't understand? SBM? Question number 1 you didn't understand? Okay. Should I repeat it again? Should I repeat? Okay then. The question number 1, limit n tending towards infinity. 1 upon n square plus 2 upon n square. 1 upon n square plus 2 upon n square plus 3 upon n square plus up to n minus 1 upon n square. So if you are comfortable in ODIA also, I can explain it in ODIA. First of all, हम कौन करें पड़े उन्हें जो series देती series टाको summation form लिखला. Summation अगर limit and standing towards infinity लिख दले. Sigma notation लगेले. इटी denominator देखो पहले सब इटी constant रोचे n square n square n square. Change के होची numerator. केतुरु केतु पर्यंत vary करची 1 करू n minus 1 पर्यंत. तले हम लिखिया sigma r upon n square. The value of r ranges from 1 to n minus 1. Is this step clear to you? Hello, SBM, is this step clear to you? If it is clear, then I will proceed. That means if you substitute r is equal to 1, that will give you the first term of the series. If you take r is equal to 1, you will get the 1 by n square. Summation means continuous addition, you know it. You know it, summation means continuous addition. So if you take r is equal to 2, it will give you the second term of the series, that will be 2 by n square. If you take r is equal to 3, you will get the third term of the series, that is 3 upon n square, like this. And the series ends at n minus 1. So limit n tending towards infinity, sigma r is equal to 1 to n minus 1, r upon n square. This is our second step. In the third step, so second step is not over. This should be written in the form of f of r by n and 1 by n. This is equal to limit n tending towards infinity, sigma r equals to 1 to n minus 1, r upon n into 1 upon n. So n into n will be n square. Now replace integration by summation, summation by integral symbol, r by n by x, 1 by n is dx. Then limit केमती बाहर करिवा ना r lower value put करिवा, limit n tending towards infinity. The lowest value of r is 1, lowest value of r divided by n. Limit n tending towards infinity 1 by n is 0. That is the lower limit of the integral is 0. Upper limit केमती पाइबा? Limit n tending towards infinity, upper value of r is n minus 1. n minus 1 upon n. Limit n tending towards infinity, n minus 1 upon n is 1. So upper limit of the integral is 1. So value of this infinite series is equal to integral 0 to 1 x dx. Integral 0 to 1 x dx will be x square upon 2. It will be evaluated between the limits 0 to 1. You know, indefinite integral of f of upper limit minus f of lower limit. 1 square upon 2 minus 0 square upon 2. 1 square upon 2 is 1 by 2. 0 square upon 2 is 0. So value, final answer is 1 over 2. I think it is clear to you. Hello, SBM. Please write in the chat box. Is it clear now? SBM, please write in the chat box. Okay, then we will proceed to next question. The next question is limit and tending towards infinity. Limit and tending towards infinity. 1 upon n plus 1 plus 1 upon n plus 2 plus 1 upon n plus 3 plus up to 1 upon 2n. So take 2 to 3 minutes of time and approach this problem. Send the answer to me through the chat box. What is the answer to this question? Limit n tending towards infinity 1 upon n plus 1, 1 upon n plus 2 up to 1 upon n plus n. That is 1 upon 2n. So this is equal to limit n tending towards infinity sigma r equals to 1 to n 1 upon n plus r. Okay. So now the next is to express the expression after the sigma notation in the form of f of r by n into 1 by n. This is equal to limit n tending towards infinity sigma r equals to 1 to n. Now divide both numerator and denominator by 1 by n. That will be 1 by n divided by n plus of r by n. This is equal to limit n tending towards infinity sigma r equal to 1 to n 1 by n divided by 1 plus r by n. So this is equal to integral 1 by n is dx upon 1 plus r by n is x. Now we have to put the limits of the integral. The lower value of r is 1. So lower limit of the integral is equal to limit n tending towards infinity. Lower value of r upon n. This is equal to 0. And upper limit of the integral is limit n tending towards infinity. Upper value of r, that is n, upon n, that is 1. So this is equal to integral 0 to 1 dx upon 1 plus x. You know, integral 1 upon x dx is log x. So integral 0, this is equal to log of 1 plus x within the limit 0 to 1. So f of upper limit log of 1 plus 1 minus log of 1 plus 0, log of 1 plus log 2 minus log 1, value of log 1 is 0. This is equal to log 2. Next question. Limit n tending towards infinity. N upon n square plus 1 square plus n upon n square plus 2 square plus n upon n square plus 3 square plus up to n upon n square plus n square. Limit n tending towards infinity, n upon n square plus 1 square plus n upon n square plus 2 square plus up to n upon n square plus n square. So this is equal to, try to solve it. SBN, try to solve it. This is equal to limit n tending towards infinity. So this is equal to sigma, limit n tending towards infinity, sigma r equals 1 to n upon n square plus r square. This is equal to limit n tending towards infinity, sigma r equals 1 to n. Now divide both numerator and denominator by n square. It will be n upon n square plus n square upon n square plus r square upon n square. Okay. This is equals limit n tending towards infinity, limit n tending towards infinity, sigma r equals 1 to n. N upon n square is 1 by n divided by 1 plus r by n whole square. So now replace summation by integration, r by n by x, 1 by n by dx. So dx upon 1 plus x square. The lower value of r is 1, upper value of r is n. The lower limit is equal to limit n tending towards infinity. Lower value of r upon n, limit n tending towards infinity, 1 upon n is 0. The lower limit of the integral is 0. Upper limit can be found by using limit n tending towards infinity. Upper value of r, that is n, upon n, that is 1. Integral 0 to 1 dx upon 1 plus x square. this is equal to tan inverse x limit integral dx upon 1 plus x square is tan inverse x. Limit is 0 to 1. This is equal to tan inverse 1 minus tan inverse 0. Tan inverse 1 is pi over 4 minus tan inverse 0 is 0. So the value is equal to pi over 4. This is the final answer. Okay. Then come to Newton-Leibniz formula for differentiation under integral sign. Quickly note this question, answer. Then we go to next topic. Then the topic is differentiation of integrals. Are you getting my voice? Hello? Am I audible? Write in the chat box. Are you getting my voice? Okay. Come to differentiation of integrals. Newton-Leibniz formula. Newton-Leibniz formula for differentiation under integral sign. Write down if y is equal to integral phi x to psi x f of t dt. If y is equal to integral phi x to psi x f of t dt, then dy upon dx, then dy upon dx equals f of upper limit is psi x into derivative of upper limit, that is psi x, minus f of phi x into derivative of phi h. Integral phi x to psi x f of t dt is equal, then dy upon dx is equal to f of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. F of x is equal to, if f of x is equal to integral x square to x cube t upon t plus 1 dt, find f dash x, okay, or derivative of f of x. Solution, f of x is equal to integral x square to x cube t upon t plus 1 dt. Differentiating both sides with respect to x. Differentiating both sides with respect to x, f dash x is equal to f of upper limit x square upon x square plus 1 into derivative of upper limit, oh sorry, upper limit is x cube. So this is equal to x cube upon x cube plus 1 into derivative of upper limit, that is 3x square, minus x square upon x square plus 1 into derivative of lower limit, that is 2x. This is f dash x, okay? This is equal to, so f dash x is equal to 3x to the power 5 upon x cube plus 1 minus 2x cube upon x square plus 1. This is f dash x. Did you understand, Sangeeta? Hello? Did you understand? Write in the chat box. Then come to limit extending towards 0, integral 0 to x t square dt upon 2x plus 1. Sorry, 2x. Limit extending towards 0, integral 0 to x t square dt upon 2x. If you substitute x is equal to 0, then the integral will be 0 to 0. So numerator is 0 and denominator is also 0. So this takes the form 0 by 0. This limit takes the form 0 by 0. So we can apply L'Hopital's rule by L'Hopital's rule to evaluate this type of limits. This is equal to limit extending towards 0, f of upper limit, that is x square, into derivative of x square is 1 divided by derivative of denominator is 2. This is equal to limit extending towards 0, x square upon 2 is equal to 0. Okay. Then next come to a very, very important property. Integral 0 to infinity f of x dx equals integral 0 to infinity f of 1 upon x square dx. Integral 0 to infinity f of x dx equals integral 0 to infinity f of 1 upon x square dx. Let's come to the proof. I equals integral 0 to infinity f of x dx. Let us substitute x is equal to 1 by t. Let x is equal to 1 upon t. So dx is equal to minus 1 upon t square into dt. X is equal to 1 upon t. Dx is equal to minus 1 upon t square into dt. If you substitute x is equal to 0, x is equal to 0 implies t is equal to infinity and x is equal to infinity implies t is equal to 0. X is equal to 0 implies t is equal to infinity and x is equal to infinity implies t is equal to 0. Thus, and integral I is equal to integral 0 to infinity f of x dx. This is equal to minus integral infinity to 0 f of 1 by t upon t square into dt. So minus sign, negative sign can be observed in the limit. It will reverse the limit. Upper limit will be the lower limit and lower limit will be the upper limit. This is equal to integral 0 to infinity f of 1 upon x square dx. This is our proof. Okay. Sangita, did you understand? Write in the chat box. Write down the question integral 0 to infinity integral 0 to infinity tan inverse x to the power 7 upon 1 plus x square dx. Clear? So this is equal to, by using the property, you can write this integral as integral 0 to infinity tan inverse 1 upon x to the power 7 all over 1 plus 1 upon x square into x square dx. This is equal to integral 0 to infinity tan inverse 1 upon x to the power 7 all over x square plus 1 upon x square into x square cancels dx. This is equal to integral 0 to infinity tan inverse 1 by x is equal to cot inverse x to the power 7 upon 1 plus x square. Okay. This is the original integral I. If you club these two integrals, I plus I will be 2I. So I plus I is equal to integral 0 to infinity tan inverse x to the power 7 upon 1 plus x square plus integral 0 to infinity cot inverse x to the power 7 upon 1 plus x square dx. So this 2I is equal to integral 0 to infinity tan inverse x to the power 7 plus cot inverse x to the power 7 upon 1 plus x square dx. Tan inverse x plus cot inverse x is pi by 2. So 2I is equal to integral 0 to infinity pi by 2 upon 1 plus x square dx. So 2I is equal to pi by 2 integral 0 to infinity 1 by 1 plus x square dx. This is equal to tan inverse x pi by 2 into tan inverse x. Limit is 0 to infinity. Tan inverse infinity is pi by 2. So 2I is equal to pi by 2 into pi by 2 minus 0. Sorry. This is equal to pi square by 4. 2I is equal to pi square by 4 implies I is equal to pi square upon 8. I equals pi square upon 8. This is the final answer. Oh, only one participant, that is DHC. Oh.